Hello students, welcome to SAM classes. Today we'll be learning the chapter Electric Charges and Fields 2017 previous year's questions. Now in the year 2017 what came up, what kind of strategy was needed to solve the questions of KCET, and what was difficult, what was easy, was the questions very too much formula based, application based, something too much conceptual. So let us understand, let us see all this in detail so that you are able to prepare yourself for the upcoming 2022 exam or upcoming whatever exam you want to put up. Okay, with these kinds of questions, how they ask it, okay, what is the timeline in which you have to solve. So our next target will be from the upcoming videos. I'll try to put up what do you say, a clock in which I'll be solving the question. I'll be showing you how to solve the question in 30 seconds. Okay, and that part you have to do for yourself so that you are in a position so that in exam you can solve the questions in less than 30 seconds. So let's start the video. A very simple chapter, very easy chapter. Around 3 to 4 questions we can expect per year from this chapter minimum. Okay, just from the first chapter. So let's see and unravel this chapter. So first thing is read the question. So question reading is one of the most important skill here. And once you read the question, decode what they are trying to ask. Okay. So first, two spheres are there, electric charges plus 2 nanocoulomb and minus 8 nanocoulomb. Okay. So students should know what is a nanocoulomb. So 1 nanocoulomb is equal to 10 power minus 9 coulomb. Okay. Just a unit. Okay. Now, so two sphere, one has a charge of plus 2 nanocoulomb and the other has a charge of minus 8 nanocoulomb, and they're separated by a distance d apart. Okay, if they're allowed to touch each other. So here, before that, when they're separated apart by d, when they're separated apart by d distance, what is the force acting? F is equal to k q1 q2, 8 into 2 16 k q1 q2 by d square. Okay, now since one is positive, one is negative, so it will be what? Of attractive nature. Correct. Now, what about the other situation? Now, suddenly what you did is you touched them. If they're allowed to touch each other, so the moment here, KCET wants you to know, the moment you touch two charged particles, what happens? Charges redistribute in such a way so that they all have same charges. Okay, they both have same charges. Okay, now here minus 8 and plus 2. So what will happen? Minus 8 and plus 2. What will be the new charges? Come on, fast. Let's see. So let us understand what we do. We have minus 8 plus 2. So basically we have minus 6. Distribute equally. So minus 3 here, minus 3 here. Done. Now what is the new force? Just magnitude we want. F dash is equal to K Q1. So K into 3 into minus 3. So 9K by D square. Now what you see, what is the difference? Now what they're telling is, what is the new distance between them? So to get a repulsive force of same magnitude. So this force and this force has the same value. So mod of this force is equal to mod of this force. Done. So what we can do? 16k by d square is equal to 9k by d square, d dash square. Okay, because that is the other distance. So what will get? D dash by d whole square is equal to 9 by 16. That is equal to 3 by 4 whole square. So answer is 3d by 4. That's it. So was it that difficult? Tell me. So nothing in this question was that difficult. Okay, so you need to understand. Okay, the question was pretty damn simple. Now let's say if in exam I have to do it, same thing in a much shorter way. What I'm gonna do? Think what I'm gonna do. Let's say this same question I have to solve it in much faster way. Same question I have to solve it in much faster way. So what I'm gonna do is, first I'll write down the charge plus 2 nanocoulomb minus 8 nanocoulomb. Okay, so d distance apart, force directly I'll get. What is the force value? 16k by d square. For the other case, I'll do it in mind. Okay, two charges, whenever they touch each other, what will happen? The charge will distribute in such a way both have equal charge. Okay, so minus 3 minus 3. So one is minus 3, another is minus 3, separated by d dash distance. So f dash is equal to 9k square by 9k by d square, d dash square. Done. So now this I'll equate it and I'll get the answer. Okay. Now for students who are good and who can see the question in solve it. They just have to do this too. That's it. Nothing more than that also. Okay. So the question was pretty damn simple. It just wanted us to know what is the force formula and how do we equate it. That's it. Nothing more than that. So only Coulomb's law was here to save us. Nothing else we needed. Okay. Not nano Coulomb, nothing. A lot of students, what happens is the moment they see nano Coulomb and they haven't studied what is nano Coulomb, they get scared and then they leave the question. Nothing. Did we use anything of nano Coulomb? Nothing. Whatever the charges, both are same. No. So forget about nano Coulombs. Correct. So after seeing the question, don't get scared and leave the question. Okay. Try to write what is given in the question. Okay. Now let's see the next question. What is the question telling? 4 into 10 power 10 electrons are removed from a neutral metal sphere. So one, you have a neutral metal sphere. Neutral means charges, positive and negative values are same. Okay, that is neutral. So the moment you have removed these many electrons, how many? 4 into 10 power 10 electrons. So basically you have removed the negative charge. So this will become what? Positively charged, yes or no? Yes, sir. Now, and what you have done? Once you have removed and you have placed them 20 centimeter in air. Okay. The magnitude of electric field at a distance of 20. Now, what is the formula? They just want you to know what is the formula of electric field. What is the formula of electric field? What KCET wants to know. What is the value of electric field? Electric field is equal to what? K, Q, K, Q by R. That's it. So K, Q by R square. Sorry, K, Q by R square. So what is the formula here? 9. Okay. Now what about powers? Do we need powers here? We can skip it also. Correct. Yes or no? We can leave the power. So 9 into charge on 1 electron, 1.6 into 4 into 10 power 10 is there. So I just took that divided by 2 square. So if I solve just this much also, it will be somewhere around 144 and my answer will be this one. Now why I didn't took the powers? Because see, there is no power game here. Okay. Every number 0 it won't be. This or this or this. Okay. So here, if I would have put up the powers, I would have got the same thing. Okay. So you don't have to worry and do make the calculation too lengthy and hazy by putting up all the powers. Okay. You can do it simply and directly. If I would have been like in a much more practice situation, what I would have done, electric field is equal to 9 into 4 into 1.6 by 4. That's it. That's it. That's it now. Okay. So electric field formula is what? K, Q1, Q2 by R square. That you should know it. The moment you're removing it, what will happen? One will be positive charge, one will be negative charge. That's it. So anything difficult in this? Anything like too outstanding, too JE type? Nothing. Very simple questions are there. Okay. Coming to the next question, a very simple question. Let's analyze this question. Now this question, understand, after reading it, a lot of people won't be able to make sense and they'll leave the question. What is the question telling? 3-point charges plus 2q plus 2q and minus 4q are placed at the corners of a equilateral triangle. So equilateral triangle, draw it. Here you have placed, let's say, plus 2q, here plus 2q, and here minus 4q. Now what will happen? A lot of people will keep it like this. Can we write it as minus 2q and minus 2q? Correct. So this one minus 2q and plus 2q will make a dipole, and this one plus 2q and minus 2q will make a dipole. If anybody is able to do this much, the rest question is a chill question. Okay, done. So we got two dipoles. One dipole is like this, and what is the direction of the dipole? Negative to positive. Direction of the dipole, negative to positive. So one dipole direction is like this, the other dipole direction is like this. So we have to find the resultant. Now in class first PU we have learned the resultant formula. What is the resultant formula? R is equal to, if you have two vector, let's say A vector and B vector, so the resultant R in between them is given by A square plus B square plus 2AB cos theta. Correct? So here in this case, resultant will be what? Root under of P square plus 2P square. This is also P and this is also P. Into cos 60 is how much, kids? Cos 60 is half, sir. Correct. So done. So what we got? 3P square. So that is equal to what? Root 3P. That is equal to root 3P. Correct. So we got that is equal to root 3P. Now we got the resultant. Now what about the charge part? Correct. Resultant is root 3P. What about the charge part? How do we solve it? Now momentum P, because see, they haven't given in terms of what is the dipole moment? Sorry, not the momentum. They haven't given in terms of dipole moment. So what is dipole moment? Dipole moment is nothing but, what is it? Either charge into the distance between them. Correct. Done. So the charge between them, let's say they have given side is x, so side is x, and the charge is 2q, and the charge is 2q. Done. Correct. So what we can write, root 3 instead of p, I can write it as 2q and x. Correct. So it is what? 2 root 3, 2 root 3 qx, the first value. That's it. Was it that difficult? So what were things KCT wanted us to know? First, it wanted you to know that if two vectors are there making at some angle, what is the resultant formula? How do you find the resultant vector? That they wanted to know. They wanted you to know how to break it into two what? Dipole form. Correct. And once you're done with that, what is the dipole moment formula? That is equal to charge into the distance between them. That's it. So that much only KCT wanted you to know. That's it. Nothing more than that, nothing more conceptual. Okay, nothing very conceptual, nothing more than that. Okay. So what we have analyzed in 2017 paper is that the questions were very, very simple. A bit of understanding was needed. They asked about dipole moment. Coulomb's law, one question was based on that, and one was based on electric field. So three basic concepts they have picked up, made three questions, and very simple. Nothing difficult, nothing too easy, crazy. Okay. So don't start solving J and all that problems. Okay, very simple KCT questions are there. Simple it is. Just remember the concept what I've given and then try to apply it. That's it. Okay. Till then, Jai Hind, take care.